over just a squared plus b squared, which is a very nice expression in my opinion. So last time we found the curvature of a helix given by this equation with these conditions. Today, let's find the torsion of the helix. So last time we have gotten the velocity and also the acceleration, namely the first and also the second derivative of r. And we also have the magnitude of the velocity cross the acceleration. Today, not only we have to use this, but we also need to differentiate this one more time. The derivative of the acceleration is the jerk, so I'll just write this down for the notation. Differentiating cosine, we get negative sign times the negative, so we get positive sign with the a in front. And then differentiating this, we get cosine, and that will still give us negative. And then this and that are just 0. So we are ready to go. Here is the formula that we are going to use for computing the torsion tau. We are going to set out a 3 by 3 matrix, and then we are going to compute the determinant of that for the numerator. And to do so, you can probably see already, we have 1, 2, 3. 1, 2, 3. Yes. We are going to pick up the components from V, A, and J, and then just set it up and then compute the determinant for that. I'll write down the general formula for you guys first though. We write x with a dot just to mean the derivative when you have one dot, and then y dot, z dot. So why are we using x, y, z? This right here is x of t, this right here is y of t, and this right here is z of t. We're just picking up the component part. Next, so this is the original, this is the derivative, right? And next we have 2 dots because for the second derivative. Lastly, 3 dots. 1, 2, 3. Yeah, it's quite fun to do this. 1, 2, 3. All right, and then we are going to divide this by this guy squared. So the magnitude of V cross A, and then we square that. Okay. Here we go. We're going to set this up. Right here, I'm just going to pretty much write this down. We have negative A sine t. Next, A cosine t and B. And then negative A cosine t, negative A sine t, 0. You can just look at this and take the derivative. Yeah, so this right here will give us A sine t and then negative A cosine t and then 0. Okay, and then over the magnitude part is this, which we got last time. So a square root of a squared plus b squared, and then we just have to square whatever that is. Now this right here looks intimidating, but it's actually not so bad because we have 2 zeros. So let's just go ahead and do the following. We are going to do the cofactor expansion about the last column. To do so, remember plus minus plus and then minus plus. In fact, they don't matter because you get 0. But here, this is going to give us positive b, and then we are just going to multiply by the determinant of this entry, like this determinant matrix. Because once you start with this, you delete this row, you delete this column. Look at that. So, looking at this, I think I'm just going to set this up for you guys. So, this let's just do it. Let's just do this. All right, just do this. This times this will give us positive a squared cosine squared, and then go the other way, but that will give us a subtraction. But this is negative, so that will turn this positive, and then we have a squared, and then sine squared. Aha. Over, okay, a squared square and square root cancel, so just a squared plus b squared. And you know we are going to see our good friend, right? On the top, we can factor out the a squared, and we get cosine squared t plus sine squared t, which is the one that we love. So the top is just a squared times b over the bottom is a squared times a squared plus b squared. And ladies and gentlemen, cancel the a squared, and we get the torsion to be b over a squared plus b squared. Which is really nice, right? Because what was the torsion? Well, of course, this is the torsion. I mean, what was the curvature? The curvature is when we have a on the top. The torsion, now we have b on the top and then divided by a squared plus b squared. Very nice.